In this video, we're going to be talking about shielding gas related to gas tungsten arc welding, or also commonly known as TIG welding. The main types of shielding gas we use for TIG welding are 100% helium, 100% argon, and a mixture between the two. As you can see on the shielding gas selection chart, we use these different types of shielding gas depending on the thickness and the type of material we are working with. This is what happens when you use no shielding gas while TIG welding. As you can conclude from the two videos I just showed, you can see when I got done welding at the end of the second video, you can see a big glob of metal at the end of my electrode. And you can also see the sparks coming off of the weld. The reason we use these shielding gases is to stop oxygen from getting to the molten pool and the TIG rod. Allowing oxygen to the weld creates a bunch of problems, including porosity. Argon gives better arc starts due to its low ionization capabilities. As you can see on the bottom bead, this is a bead I have ran with no shielding gas at all. And on the bead in the middle is one with the just amount that you need to make a weld that big. And on the weld on top, I used too much shielding gas, therefore it came out with a flatter appearance. In this next clip, it's me welding with a mix with helium, argon, and CO2. Here's the welds resulting from the mixed gas combo. You can see I left the brown soot around it, telling me oxygen has gotten to the weld pool. Here's a cut and micro etch of those beads I just showed you. As you can see in this picture, you can see the bead penetration depth. I did this so we can see the bead penetration for the weld. For TIG welding, we use a pressurized gas cylinder with the use of a flow meter to control the amount of gas we are using during the welding process. You want to be able to set the lowest pressure possible for the weld that you need to complete. That way you have a good laminar flow, and if you run the pressure too high, you have a chance of running into turbulent flow and you'll get uneven gas coverage. It's cheaper and more cost effective to use argon or an argon mix for its arc capabilities and its availability. To calculate the amount of gas you used on a weld, you want to be able to look at the regulator and see the amount of CF you have used up on the gas tank. From there, you can take the price of the tank and divide that by the amount of CF the tank can hold. And that will tell you the price of gas per CF that has cost you. For example, if you take a 120 CF tank, which is $389, and divide it by 125, it will equal $3.11 per CF. So you use it for a welding job and use 3 CF, that would have cost you $6.33 of gas.